In this video, we're going to discuss dilutions. So a serial dilution is where we create going from our most concentrated all the way down to our least concentrated. So one of the things with a dilution is we, one, must go from a concentrated to a less concentrated. When we think about this in terms of a beaker, if we have a sample here, and we'll say that this has a concentration of 2 molar, and we're going to go ahead and color this blue. So when we create a dilution, we want to take some of the blue, oh look, blue pen, into a beaker. And in this case, we're going to make it the same volume as before, but in this case, we're going to take part of the blue and mix it with green, where the green is the water. And so this is going to be less concentrated. It's going to be less than 2.0 molar concentrated. So a dilution is our ability to go from the stock solution over here into a new solution here. And so it turns out that mathematically, using the concentration of the first stock and the volume of the second stock, we can start to calculate this. So if I want to make 250 mils of a 0.100 molar copper sulfate by diluting a 1 molar stock. So how many mils of the stock should we use? So in this case, we need a plan of attack. So our plan is to, 1, determine moles required. And so we're going to do that by taking our concentration of 0.100 moles over liter, multiplied by our desired volume in liters, which is 0.250 liters. And that gives you that you need 0.025 moles of copper sulfate. So once we know the number of moles, we then need to figure out determine the volume of stock. And so we can do that by, in this case, we're going to take our 0.025 moles of copper sulfate times the fact that there's 1 mole and 1 liter. So there's the concentration of the second. And so we need to have 0.0250 liters of the 1 molar stock, which is that you need 25 milliliters of the stock in order to create this calculation. So this is the long-handed method in order to determine part of the information about that. It turns out that, as we know, scientists like to develop quicker, faster methods to do this. So a faster method is M1V1 equals N2V2. So in this case, we have on the left side, we're going to have M1V1, and this is going to be for the stock. And it's going to equal M2V2, and these are for the dilution. The M is for molarity, and these can be in any unit, moles, or this should say in molar, millimolar, etc. The volume is any volume as long as they're the same. So this equation allows us to convert M1V1 equals M2V2. So this is an equation that I use frequently in my research group. It's probably one of the most useful equations in Gen Chem 1. So we have a little note of caution here. And so our note of caution, it turns out, is that this works really well for a dilution. It does not work for a titration, even though it works sometimes. So M1V1 equals M2V2 is most useful or useful when these samples are the same. So while we haven't quite talked about titrations yet, that's a different set. M1V1 equals M2V2, the molarities have to be of the same component. And so let's look at some examples. So we'll do, this will be example 1, this will be example 2. So our first example, how many milliliters of a 3 molar sulfuric acid solution are needed to make 450 milliliters of 1 molar sulfuric acid? So whether or not you know that the chemical formula for sulfuric acid is H2SO4, it's a strong acid with 2 protons. The hardest part with this is making sure that your M1V1 equals M2V2 is consistent and set up for the right ones. What I mean is that these two are going to be your dilution. This is going to be our stock. So when we set up our M1V1 equals M2V2, for this question, we know that we have a 3.00 molar, and this is going to be V1, which is what we're going to solve for, and then we're going to have 0.10 molar, and we have 450 milliliters of that. So it's asking for how many mils, so we can leave the volume in milliliters. And so when we use our calculator, V1 is going to be 15 mils of 3.00 molar H2SO4. So again, the trick is to think about this and realize that we have a stock and a dilution. So it should be relatively simple. So let's look at example number 2. So how many mils of a 1 molar glucose stock are used to make 500 mils of a 17.5 millimolar solution? So we know that this is going to account for our dilution, and this is our stock. So we can set it up almost the exact same as we did before, where M1V1 equals M2V2. In this case, we know that we have a 1.00 molar stock, and we're looking for volume. We're looking for a 17.5, and this says millimolar, so we have to convert it to molar. And so that would be 0.0175 molar multiplied by 500 mils. So when we solve for V1, it equals 8.75 milliliters of a 1 molar stock. So dilutions are relatively simple in that you can look at, by identifying both the stock and the diluted solution, you can then go on and create other parts, calculate for something else. So here are some, let's go through a game plan. So dilution game plan. 1. Ask yourself, is this a dilution? If so, we can proceed to step 2. Identify the stock, both molarity and volume, and dilution, molarity and volume. Your third step is to set up the equation. So dilutions are so simple. The hardest part is remembering that it has to be a dilution and identifying what it is actually looking for.